thermal view survey software provided by Phoenix Temperature Measurement is obviously designed to help you with the specific task of performing a temperature uniformity survey. The software therefore comes with two unique modes. One is the conventional thermal view survey, as with other softwares where you actually have all of the analysis and reporting capability. But specifically for use in a survey where it's very, very important, there is also a real-time mode or tab option. You go to the telemetry on the pull-down menu and you open the telemetry window to access that capability. The real-time tab allows you to see the real-time data being generated from your data logger either via USB real-time connection or RF telemetry live on the screen. This helps you then fully control each and every survey level that you're monitoring and see the data direct from your furnace. So there's no wasted effort of guessing whether or not your TUS has passed at each level. With the Phoenix system, we can offer two ways of performing real-time operation. The first is with a unique RF telemetry option with the conventional data logger. And this is obviously the preferred option if you're using a thermal barrier and you're putting the system into a furnace, either a batch furnace or a continuous running furnace. The data being collected from the data logger therefore is transmitted back to the computer where it's viewed in real time using the RF telemetry link. Alternatively, you can use a conventional logger or a standalone logger like the PTM 4220 external to your furnace, and you can then trail the thermocouples into the furnace to your TUS frame, and then the data is transmitted from the data logger to the computer running the thermal view survey software using the hardwired USB link. Whether using RF telemetry or USB hardwired connection, once the system is running, you would go to the real-time tab and you can then see both graphically and numerically the data that's coming back from your data logger to the computer screen. You can then see where your temperatures are in the furnace, whether you've achieved your TUS level, whether you're within specification, and I'll talk about this later on, where you can apply the TUS levels to see whether you are in spec, but that's in a later video. But at the end of the day, you can see everything that's coming out of your furnace live on screen. Once you've got the data collected at each and every TUS level and you're happy that you're within tolerance, you're within the bands, you obviously have to stop the real-time run. That's simple using the very evident stop and save button. And that will then save the real-time run in the conventional results database with this unique suffix of RT, which indicates that that data was created from a real-time run, either RF telemetry or USB hardwired telemetry operation. During the real-time run, obviously the data is being stored inside the memory of the data logger. So it is good working practice, in addition to the real-time run that's been saved in the database, to download the data directly from the logger, which means you then have a backup copy of that real-time run. In any real-time telemetry, there is a possibility there might be some data gaps, particularly with RF telemetry. That's going to be minimized using the Phoenix catch-up feature. But if there are any data gaps, they obviously won't be present in the downloaded data. So you have a complete confident data set to do your TUS analysis on. So we have our two files, our RT file, our real-time file, and our conventional downloaded file in the database for future review, analysis, and reporting. What I'd like to do now is demonstrate how to perform a basic real-time temperature uniformity survey. We're not going to go into detail about analyzing the actual data that we're collecting. I just want to go through the fundamentals of the steps you have to take to set up your data logger and start the real-time run, and then save the data at the end. In a later video, we'll cover how to actually analyze the data, maybe even real time, but in the downloaded data afterwards. So I have a data logger connected to the thermal view survey software on screen with a comms cable. I'm going to go to the new survey button. We're going to establish communication with the data logger itself, and I'm going to select real-time measurement. So this would be if I've got an external logger to a furnace and I'm trailing the thermocouples in. I could also be using RF, but for the demonstration it's probably easiest if I use USB. So the data logger is external to the furnace. The thermocouples are going through the front door of the furnace to the TUS frame, and we're going to be monitoring the temperature of the thermocouples over that TUS frame through the process of the survey itself. Real-time measurement, USB. Click Next. Comes up with the data logger settings box. You can see here the data logger has 10 channels, but I'm going to actually just use 9 for the TUS, and I'm going to choose a sample interval of 2 seconds for the demonstration. Press reset. Confirm the messages that come up. The data logger is resetting. The software is looking for the data logger it's connected to, and I'm now seeing the data coming in live on the screen. So you'll notice at the top of the screen there is 2 tabs. One is real time, which is the operation mode we're in at the minute. So we're reviewing real data as it comes into the software. Later on, we would then use the thermal view survey tab that we've looked at in previous videos for all of the data review and the analysis. So all we're doing in this video is identifying how to capture the data so we can then apply the principles of the temperature uniformity survey analysis. Data's coming in nicely. I'm now going to replicate what would happen in a real-time furnace. So I'm going to start to ramp up the temperature, and the software should auto scale to reflect the data that's coming in. And I'm going to go up to something like 600 degrees as our typical TUS temperature. We've actually gone over that slightly, but we're now achieving our temperature at just over 700 degrees Celsius. You can see the graphical view. I can zoom into this if I want to, and the data is live in the table below as it's refreshing on screen. So this is how you would operate the software in a real-time operation. Very, very simple. I'm not going to do any more now in terms of applying things like TUS levels or TUS frames or correction factors, because I'll do that in another video. Once you've finished the run, it's as simple as pressing the stop and save button. So I'm going to do that now. It comes up with a command. Am I sure that that's what I want to do? Yes. Okay, I put in my name, and I'm going to just put test TUS at 700 degrees Celsius. Click OK. All right. Now, the TUS, the real-time tab doesn't actually show any real-time data, but if I click back to the thermal view survey, you'll now notice that in the analysis tab or the database, there's now a new entry which is dated the 17th of the 4th, 2025, 12:53 when the test was performed. You can see here the operator Steve and the notes I put in. Interestingly, alongside the suffix is RT, which means that this data was collected via real time. This data can now be analyzed using all of the analysis features in the thermal view survey, but we'll talk about that later. One thing we would recommend to customers is possibly even downloading the data from the data logger memory, so using the download button, and that would then create a backup copy of that particular real-time run. It's unlikely that there will be gaps in the data in a real-time run because of the features like catch-up for the RF telemetry, but often people like to just make sure that they've got all the data backed up and secure from the downloaded file. So if you want to download the data, simply connect the data logger again, press download, and you'll then have a download file with no suffix of RT, as is conventional, and you can then do the full analysis on that.